Hello, everyone. Thank you for joining today. Today we have Philip Seamark presenting Creative DAX. Philip, without wasting any time, I'll give you the floor.
Cool, thank you. Hello, everyone. Welcome to the session. Good morning, good afternoon, good evening, wherever you are and whenever you are, if you're watching this on a recording. My name is Phil Seamark. I am currently, until the end of this week, a Microsoft Power BI MVP. But on Monday, I am joining Microsoft. I'm joining the Power BI Cat team, which I'm pretty excited about. So one of the more famous members of the team, Adam Saxton, is better known as Guy in a Cube. He's one of those people on the team. Yeah, I'm really looking forward to joining the guys that build this fantastic product that I'm going to be showing you. Hopefully you can see my screen. Here's a picture of me. I have if you want to contact me about any questions during the presentation, feel free to contact me on Twitter or LinkedIn. There are my details there. But let's go over to the session. The first page I would like to show you is a website called DAX.tips. And if I just zoom in here to the address bar, just type that into your browser if you want to follow along. On this website here, what I'm going to be doing is working through a series of games that I've built in DAX. This is the whole meaning of the topic, creative DAX. So we're going to walk through some of these. Now, for each of these, you can click on the link to blog to go and get much more detail about anything that you've seen of interest. You can download the PBIX file to your local machine and open and explore the code, get hands-on and see some of the things I'm talking about. But we can also see the game live just by clicking on the Play Live tab. So just if you load up DAX.tips in your browser, you will arrive in this page. It'll automatically append on the games to the URL. Also, I have a text file which you might want to open. This is my run sheet, so these are my notes about what I want to cover. If you open that, print it, have it available on your screen, then this is what I'm going to be going through for the session, if you find that helpful. So why creative DAX? Why games? I was curious myself to use games as a way to explore the capability and maybe perhaps find some of the boundaries of DAX. I spent quite a bit of time building business-based reports, creating measures like sum of this particular column, average of that particular column, maybe creating more complex calculations that allow you to do things like period comparisons or trends over time. And very slowly over time starting to create more and more complex calculations. And I thought it might be fun to actually try some different techniques. So the very first game I started, which was about 6 months ago, was I thought I would have a crack at a game called Blackjack. And let's just have a look at that, what that looks like in the published to web site. And when you see the game, then we'll come back to the code and have a little bit of a look to see what's going on. Now, a lot of these games aren't necessarily 100% DAX. They're a mixture of DAX with bookmarks and buttons and images, etc. Let's click to play this. Now, with this Blackjack game, it only plays one hand. It doesn't allow you to bet. I can get a randomized set of numbers. So I've been dealt the 4 of diamonds here. I can choose to hit. 4 and Jack is 14. I might hit again. And I'm going to hold on that because I'm 15. And when I click the hold button, the house deals out their cards and goes bust, so I actually win. And let's fire up the code to see how that was built. Just bringing across my Power BI desktop file for this. So to get this working, what I did was I created a series of random numbers to generate the cards. I would create a random number between, say, 1 and 15, 1 being an ace, 2 being a 2, 3 being a 3, etc., 10 being sorry, 11 might be a jack, 12 might be a queen, etc. I also create another random number between 1 and 4 to decide what suit that's going to be. And then I create a calculated table that works out based on whether you're hitting or holding what your score should be, and eventually comparing that with what the house does. So it's not a complicated model. What we're looking at here is a handful of tables. They're not connecting. And the logic for the game is in a little bit of DAX here that just takes these random numbers, assigns the card values. You can see that there's a column here that controls what turn you're up to. Now, probably the trickiest thing in here is how to handle the ace card, because an ace card, if you're familiar with Blackjack, can either represent a 1 or an 11. And when you have multiple ace cards, you want to identify what is the best score for the player, because you may potentially get 3 or 4 ace cards. So there's a little bit of code in here. Makes good use of DAX variables. I'm not going to go into every single line by line for this because there's a lot of code to get through, but essentially the core logic for this particular game is held in a single table. There's a calculated table that's created in DAX. The other thing I wanted to just show you was the selection panel for the game page consists of a series of buttons that are sitting one on top of each other. And what happens is the hit 1 button is visible to you initially, but the hit 2, 3, 4 buttons are invisible, and they're all sitting one on top of each other. And when you hit the first hit button, it disappears via a bookmark and it presents to you the second hit button. And each of those is connected with a piece of information that can tell the game exactly where you're up to and what to do. And importantly, when you hit the hold button, that then sends the signal to the game to play out the house game. So it's not a particularly sophisticated implementation of Blackjack. It probably was when I first sat down and did this because it was my first game. And when you have a look at what we get to, you'll see how these have evolved into richer and more complicated scenarios. So that's the first one, Blackjack, and it's a little bit of fun. There's probably the main DAX logic that you're likely to see is the code in the player 1 table. So if you're going to download, have a look at that one, go there, and feel free to let me know if you have any questions. The second game I created, when I just find my browser, sorry, here we go, DAX.tip, Sudoku. Let's have a look at this. So I searched the internet and found now this isn't a Sudoku solver. This allows you to play the Sudoku game. So I searched the internet and found some pre-played games in CSV format. Now this format shows a number of clues, and you might get 15 clues in the game, and you have to solve it yourself. Now, this is probably the least favorite of my game because it's very, very heavy on CPU, and it's not the prettiest game. I have a large number of slices here. Any slicer with a large block is a cell that is a clue. So in this matrix of 9 squares, what I can see here is that I know that this particular cell in the very top left-hand corner is an 8, and I have to make a selection of what I think the cell next to it should be by making a selection on a slicer. The next block over here has a few more filled out. So if I want to say maybe make this a 9, I can click on that, and that selection will recalculate and let me know how I'm progressing. That is the correct value for that particular cell. That's quite lucky. Now, what I learned when I was building this game was when you add an object to the Power BI canvas, it sits inside an iframe. And inside that iframe, there'll be its own internal JavaScript client to talk to the rest of the objects on the same canvas. So this is how the magic of cross-filtering and selection actually works. For this game, what I had to do was add 81 slices. So 81 objects starts to get past the point where it's probably a little bit too heavy for a single page, because every time I interact with any one of these objects, and you may have seen when I click the button 9, a whole bunch of little timers came up to say, hey, I'm trying to work out what's going on. And it was quite slow. It took a few seconds. So it's not snappy, but if we have a look at the game logic, I'll fire it up. Sudoku. And the main DAX is really to walk through the tables that are connected to every single one of these slices to understand what selection has been made, compare that with the actual solution stored in the database, and then decide how you're going in terms of the progress with the game. So this is just firing up. There are a large number of objects, a large number of bookmarks. It's taking a little while to fire up. Probably has included maybe the full slicer set. Sorry, full data set of 1 million rows. I kind of like the Sudoku game to play as a mental challenge. View the selection panel. The selection panel that we're going to see shows all of the objects that exist on the given page, and you can see the amount of work, the heaviness of having so many objects on a single Power BI report that it has even on Power BI desktop. My laptop that I'm presenting on is not a shabby one, and it's taking too long. In fact, I might kill this because we only have an hour and move on to some of the more interesting games. I think the key thing here was my learning is when you really start to get more than about 40 or 50 objects on a single Power BI canvas, then you're going to start to have performance issues because of the heavy amount of work that goes on. Now, once it's published to the web service, you've got the advantage of the more powerful machines, so it does speed up. But yeah, I might kill that. Cool. So the next game I decided to have a look at was Tic Tac Toe, which, depending on where you are in the world, it might be noughts and crosses. I think there are some other variations on the name. Now this is fun in that it's interactive. I'm going to jump to the publish to web version here, and this is going to load up what we can hopefully see, the classic 3x3 game board, where I can start by clicking on one of the cells. Now, I was lucky enough from this game onwards to start getting the guys from PowerBI.tips to build the graphics. If I showed you this game without the nice game board, it would look quite ugly. So I'm going to start by clicking in the top left-hand corner, and that's going to place an X. And what's happening is the DAX is responding with a naught in the center. So I might try and win by coming over to the top right-hand corner with my X, and the DAX is going to respond. Now I have to be careful here, because if I don't click here, I'm going to lose. And again here, now I'm going to make a mistake here just to see that it is going to win the game properly by clicking in the bottom right-hand corner, and I lose. So how do I do this? Is there AI and really super smart algorithms built into the DAX? No, not at all. I'm nowhere near that. I'm not smart enough to be able to write that sort of thing. So the way this game works is it uses a data set of pre-played games. I'll show you the file of games, what that looks like. But to do that, what I needed to do was assign each square in the report an ID. And I started by top left going 1, 2, 3, 4, 5, 6, 7, 8, 9. That's just logically how I like to think, left to right, top to bottom. Then I realized I need to keep track in DAX of the pieces that have been played by the player. Now, every time you click on a cell, there's a bookmark there that flicks a slicer, an independent, disconnected slicer from 0 to 1 to say that the user has clicked here, here, and here. And what I did was I assigned each square a binary number. So 1, 2, 4, 8, 16, 32, 64, 128, 256. And then what I could do is combine those numbers together to get a single value that could represent exactly the positions that have been played by the player. So if we have placed a square here in the top left and the top right, well, that would be binary 1 plus binary 4. So a value of 5 would represent that 2 pieces have been played, and the places I would know from that number exactly where those pieces are on the board. And Tic Tac Toe. And I'm just going to open up in an Excel spreadsheet the file that Power BI this game imports to understand what in fact to play. So here we go in Excel. So if the first column here represents all the combinations possible for the human moves. The middle column tells the game what was the most recent move made by the human. And then the final column represents what the computer should respond with, because one of the big things that's missing in DAX, one of the main challenges you have to solve when you're doing this kind of work in DAX is there's nowhere to store state. It's very you can click on a button, you can click on a slicer and have slicers selected. So if the human is interacting with the report, they can make they can set a state, but the computer can't really. There's no way for you to set state outside that. So here, what happens is we can see that when the human has made plays in squares that total 3, I can tell that this is top left and top middle. So the computer should respond with the binary values that sum up to 260, which will be the center square, 256, plus the top right-hand corner of 4. It's just me doing some very quick mental arithmetic. Because what I realized was I was going to have to run through a large number of permutations for this data set. But what I realized was in the Tic Tac Toe game, here we go, on the board, realistically, the human player can only start in one of these 3 squares. Sure, they might start in the bottom right-hand corner, but if you rotate that round 180 degrees, realistically they're starting there. Or if they start in the bottom center, rotate that round 90, 270 or 180 degrees, they're really starting here. So I only needed to develop the number of permutations based on the human player starting in one of these 3 squares. And then once I had played those out, then I could just make copies of those rotated 90 degrees, 180 degrees, 270 degrees, and also I could flip them horizontally. So my data set of pre-play games contained about 100 entries. I can tell you this, exactly. It was actually 145. But once I multiply that out inside the DAX engine, then it's well over 700, 800 games. And what you don't realize is that when you reset the board and perhaps start over here, the computer will always respond with the pretty much always the same response, but rotated. So let's have a look to see what that looks like inside the game. Oh, the other key thing is I needed to, initially I used my binary values assigned left to right, top to bottom, but then I realized my rotation was going to be a lot easier if I assigned the binary values in this rotated way. So we can see here that the top left is 1, 2, 4, but then I rotate around the outside to be 8, 16, 32, 64 like this. And that means when it comes time to rotating, I can take the numeric number 256, convert that to be binary, turn that into a string, and then just take two values off here and put them at the front. So like just do some string manipulation, and that's how I can very easily create the rotation. Now DAX doesn't have any native bitwise functions. There is no concept of binary and or binary or in terms of operators. So I had to create my own. They're built into the game, which was quite fun from a tech geeky perspective. So I created a table with binary and decimal representations, and then I could use on-the-fly DAX lookups to say, hey, if I've got a numeric value of 17, then in this table go and find what the binary representation of that is. And there's some pretty neat DAX that generates the binary value that I would recommend you have a look at. This is taking a little while to fire up. Cool. Oh, so there's a binary mapping table. So value 17 equals that in binary. And I've got some quite neat DAX that generates, because of the lack of native binary functions inside DAX, there's some quite cool DAX calculations in here that show you how you might do that. And then what happens is the code here will, there's a calculation that goes and figures out what positions have been played by the user, and you might have played 4 pieces, and you might have played a piece in that square, that square, that square, and that square. If you have done that, it'll create a string 0, 1, 0, 0, 0, 1, 0, 0, 1, etc. Then it will go and look that up down in this column and then find the decimal value, and we can do some calculations there. And with that decimal value, I can go to the pre-played games and say the user has played 19, so what should I respond with from my pre-played games? And I might have to respond with a value of 260 again, and I will take the 260, so the player 2 position, will scan down here and find that, go find the what that represents, and then place an image or a graphic in the squares where there is a 1 for that response. So no on the fly AI. I would like to say maybe I use some AI to generate my data file for this, but I didn't. It didn't take too long. It probably took me about an hour and a half just sitting one evening working through the permutations, and it's mostly right. There are some scenarios where it does get a bit confused, because particularly when you've played 4 pieces, it doesn't know the order that you've played those pieces. It can tell the very last piece you played, but it doesn't know the order of the first 3 pieces you played. Now, and the order is important if you try and understand what the computer maybe had responded for that order. So it gets it right about 95% of the time. Mostly, if you look at this and click on play a couple of rounds, then it will behave like as you would expect for a Tic Tac Toe game. So, but the most of the interesting DAX logic is stored in these calculated measures here in the binary mapping table. So feel free to pull that apart. And like I say, reach out, fire any questions my way. I do go into this in much more detail on the blog, which you can see in the link on the DAX.tip site that is over here. So the next one was Hangman. Let's have a look to see what Hangman looks like. So this is just guess a word. Now for the library of words, I thought I'd be educational and I used the DAX function library. There are about 130 DAX functions. I don't know them all. Now the idea here is you can just pick a random number. We're going to start the game. And again, I've got a wonderful graphic board provided by the guys at powerbi.tips. Now here we have a word that we have to guess, and the word has been represented by these underscores separated by spaces. We have image buttons here that are linked to individual tables. So there are 27 letters that you can guess, because some DAX functions can have a decimal point in them. So there will be 27 disconnected slices. Now these tables, only have a value of 0 or 1 to say whether you've clicked on the letter that represents that. And every time you make a selection, a calculator measure can scan all of those tables to go, okay, are they all zeros, or which ones have a 1 set? And then I can, from that, understand whether I need to present a letter here or remove a bar from one of these. Now, this was the first game that I started playing with SVG inside these games. Up till here, everything had been using native properties and objects inside Power BI Desktop. And then mid last year, a guy, David Eldersfield, he was coming out with some quite cool SVG-based Power BI reports, spark lines and KPI reports, and this is pretty cool. It allows you to generate graphics, text-based graphics. SVG is very XML text. You can create circles, lines, polygons, etc., and set properties in it, and it draws really well. So for this icon, I drew this as an SVG, and then if you make a correct guess, your letter shows up here. If you incorrectly guess, then you lose a value. So let's assume that there's no Z in this word that I don't know. I'm going to click on that, and we should probably see a tooth disappear. We've made one guess, and we have 4 chances left. I'll try a more common letter. Okay, so this word has got plenty of those. We can show a hint, because I don't want to spend a lot of time on this. The hint here is probably giving it away. I need to probably remove this URL from the hint, but this is telling me that the function is the generate function. So we can complete this by just clicking on G, N, T. Let's guess wrong again to lose another tooth. 8 and R, and it'll tell us that we've won. So there's not a huge amount of DAX involved in this. To build this game, it was more an exercise in adding buttons, bookmarks, and tables in the background. And I'll show you what that game looks like. Hopefully it doesn't take too long to load up. And the minimal amount of DAX was really every time you've interacted with the game by clicking on a bookmark, then it just does a bit of a scan of those underlying disconnected tables to go, okay, I know that you've clicked on the A letter, I know that you've clicked on the T letter. So based on that, I can compare with what I know the word is I'm trying to guess, and I can set the values in these text-based measures or update the SVG that we are presenting. Cool. So if we jump to the report page, and turn on the selection pane, we can see that there are a large number of buttons and slices and bookmarks. So the A button is linked to the bookmark letter A, and the bookmark for letter A performs an action which is designed to set a selection on a table from 0 to 1. And if I look at the relationship view, you'll see there are, when I scroll across, table A, table B, table C, table D, all the way down to table T. And if we have a look at the contents of one of these, because they all share the same, table A is simply a 0 or a 1. And I have a bookmark that sets a slicer to select this row when I click the A button, and it just stays selected. And then there is a measure that runs through and decides how you're going. And here's an example of guesses, and it can just test the value of each of those. If they're set to 1, then decide what to write. Now, the trickiest part here was that when you click on an A, or in this case an E pops up 3 times in the function. So it needs to not just put the first one, it needs to go and correctly display the letter E instead of an underscore where appropriate. So in this version, the DAX is here. So cool. Minesweeper. Here the DAX starts to get a little more advanced. Up until this point, I would say I don't really have any advanced DAX up until this game, but this one does. Now, if you're familiar with the classic Windows Minesweeper game, the idea is you have a matrix. My matrix is 9 by 9. There are 10 bombs hidden in this matrix. If I click in the top right-hand corner of any square, it's like me saying, I think there is a bomb there, and it will place a flag. Or if I click anywhere else on the square, it can play the game. Now, one of the interesting things about this game is when you have a cell with a number in it, it's very easy to work with because you just display the number that's associated with that cell. Or if you happen to click on a bomb, then you can display that. But the trickiest part of this game was how to deal with these regions, because these regions, the squares that sit outside the numbers, they're very irregular shapes. And they can go around the corners, they can cut back onto themselves. And what I needed to develop was a method so that whenever I click on any one of these squares, the whole lot reveals, as opposed to just itself. And that was quite a challenge. And it took me a little while to come up with a method to decide how this should work. I'm just going to play this a little bit more, put a flag there. I will maybe step on something to fail, get the idea. Cool. So I've stepped on a bomb there and I've failed. I'm going to fire up the game. Mission Possible, Minesweeper. And again, this particular game has a high number of objects. I used the classic matrix to control the standard matrix visual inside Power BI to do the columns and rows, but on top of every single square, I placed a Power BI button. In fact, 2, one to handle the clicking to step on the square, and a smaller one in the top right-hand corner of every single square to do the flag. Now, it's not as heavy as that Sudoku game. Now, part of the reason why the Sudoku was really, really heavy was because the 81 objects were all slices, and slices do a lot more talking than standard objects. So it's a little heavy, but not so bad. And if we see the number of objects that are involved in this, and I go to the game page, there we go. So there's a whole bunch of buttons. So row 1, column 1, button flag. These ones should actually be named a lot better. You can, when you're using the selection tab, set the title for the object so that you can much more easily track what it is when you're dealing with a large number of objects on a page. So you can see here's an example where on a local machine, it's this is not too bad. It's just not as quick as the engine once it's published. Oh no, just come on, wake up. Because I want to get to the game logic where I can show you what's going on in terms of those, revealing those squares that have no flag, a bomb flag, or they're not adjacent to, and how I resolve those. What I might do is jump back to page 1 here, get rid of another PBIX file, don't save that. And let's not save this. Right, so once again, there are a large number of tables. Each table has a 0 or 1 value, and it represents a particular square in the matrix. So this table here that I have highlighted represents the cell at row 2, column 8. So it's down near the bottom, row 2, column 9. So I have a series of bookmarks that when you click on a cell, it will set this from 0 to 1. So that's how the game knows where you have stepped. That's easy. What we need to do is have a system that can reveal areas where you perhaps haven't stepped. So the board we just had a look at, I clicked in the top left-hand corner and it revealed these items here. So this is what I mean. I can tell for certain cells where there is a mine, and that's my starting point. The X's here in this matrix show that's where the mine or the bomb is going to be. And when I know where there is a mine, I can then write some DAX to go adjacent squares, what should the number be? So because this 2 here is above and below a bomb, it quite rightly selects a 2, but I needed a method to join all these cells together. So what I did was every single cell has its own number, 1, 2, 3, 4, 5, 6, right up to 11, 12, etc. And if I show the base region, cool. So of the squares that are not an X or a number, these are the remaining squares, and we can see the unique IDs for these here, but I need to join them together, and I don't want to join this region to this region here. So what I did was I wrote a series of passes to say, okay, let's do a horizontal pass, and for all cells that are connected, set their value to the minimum value in that connected row. So here we've got 1, 2, 3, 4, 5, 14, 15. When I look at the calculator column that does this pass, these values should all be 1. So we'll put that into the matrix here, get rid of the measure. Cool. So it's aligned all these horizontally, 58, 65, 75, and 81. So that's cool. Now the next thing to do is do a vertical pass where I do the same thing, and where I say for all connected values, set them to the minimum value in that connected set. So importantly, I don't want to set these 3 values to a value of 1. That would be bad. So let's see how that looks. We'll look at the vertical pass number 1. V1 is for vertical 1. Cool. So this block's all connected. They all share the same ID now, which is nice. But over down here, we've still got 58, 65s, and 81. So I need to do another couple of passes. So we'll do our horizontal 2. And this all happens when you load the game up. And we still have some numbers. So what we need to do is these 58s need to be moved down. So we'll go vertical 2. And one last pass. And I found that 3 horizontal, 3 vertical passes were enough for the 9x9 matrix to handle even some really peculiar scenarios where they wrap around on each other. So now we've got the squares on the region, they share the same ID. So we can say they belong to the same region. Cool. So I now know when you click on a square that is an A, I can reveal any other square that has now been associated with A. And if we see what that looks like in calculated columns, here we go. So we can see the XY value is the row. These are the values with mines in them. And then the calculated columns just happen one after the other to sort of derive that effect that I just showed you. And there's quite a bit of DAX here that establishes that, because the key thing is to make sure you're finding items that are connected in your row, but not others that happen to be in the same row but are not connected. And we finally can walk left to right to work out exactly what region these values should be. And that's the magic. That's once I've broken that back, the rest of it kind of falls into place, and was fairly easy to implement. And I'm pretty happy with it. Let's click down on one of these B squares and see if we can show that, if it's going to speed up for me. Maybe it might be up here. So let's reset. I think this might be using the same square. So let's click on that. And in theory, when you refresh, you get a new set each time. There we go. Cool. And if you want to play this game, go to dax.tips, go to the play to web, and see how you get on. There's a little bit of weirdness about the alignment on the second move. Sometimes it squashes up a little bit, but as you get into the third, fourth, fifth move, it comes right, and it's fine. So now then, for my second to last game, I thought I would have a crack at a maze game. I originally thought I would take a matrix and have the ability, using an up, down, left, right arrow, to walk around a maze. And unfortunately, the matrix was a bit flicky. So what I did was really get into the SVG aspect of Power BI. So we have a game here. And when I click on this arrow here, we can see a maze. There's a mini maze version to show where we are. We're this little red dot in this maze of data, and we're trying to get to this spot up here. We're controlling this little character, and when I click up, the little character is going to move up, and I can zoom this in to make the map larger if I want. Let's go right out. And you can see him moving around. So how does this work? Now, I knew I was going to have a table inside the data model with XY positions where walls should be. And that would allow me to do the sliding window of plotting. I knew I wanted to do something like have a maze that spelt out a word, maze of data. And when I sat down to decide, am I going to have to hand code all of these positions where walls should be and not where walls should be? This is going to be really difficult in DAX. Then I realized, hey, I can probably just do this in a CSV file and then import the CSV file, and then using the CSV file, have some clever DAX that plots the walls. And I'll show you what this CSV file actually looks like. Just got to find it on my computer. So over here, maps, so level1.csv. If I open that in Excel, the reason why you could use any CSV or text editor. Why I like Excel is because you can align the columns to kind of look like what the map's going to be. And if I decide to, I'm going to take out this wall here, and I'm going to put a wall in over here just by putting some X's in. I'm going to save that. So this allows you to create customizable maps. Jump back to the game. Oh, I need to fire it up because the version we're seeing is the published to web game. From with DAX. Now, each of these little squares is a 16 by 16 sprite. I have about 20 of these. Some of them are stubs on their own. Some of them are corners or T-junctions or horizontal or vertical lines. So what I can do when I import the CSV file is, first of all, pivot it to be a tall table. And then for every single cell, it can work out above and below it, next to it, what sort of shape it should be. Should I be a corner? Should I be an up or a down? Or should I be a stub, for example? Let's go into the game page, and I'm going to refresh the screen, the data file, to re-import that CSV that I just modified. And what we should hopefully see is on the mini-map the updates appear. And it's a fairly tiny logic. There we go. And if we go into the game, have a bit of a look around. Come on, there we go. There's that wall that I just added. So you could create your own customized map based on your logo or a word or anything you like. It's just smart enough to know, based on, for every single cell, what's above me, what's next to me, so therefore what shape should I put in. And I'll show you what the shapes would look like. The sprites are, here's the sprite name, and here's the sprite content. So there we go. So here's corner 1, corner 2, corner 3, corner 4. And there aren't many. And the game logic is an SVG, which is a single calculated measure that has some tests. So we decide for every single given cell on the map, go and figure out what's above me, what's the sprite above, what's below, what's left, what's right. And then a nice big case statement to say, hey, if I am a wall, and the sprite above me is a wall, and the sprite below me is a wall, but the one left and to the right is not a wall, then use sprite vertical. And sprite vertical in this case would be one of these ones here. So in that case, it would be displaying that sprite there. And this all sits inside a set of DAX concatenate EX functions. Now, concatenate EX is like a loop within a loop. For each, so I can concatenate rows, and then for each row I can concatenate columns, or the other way around. I forget. I think I'm concatenating rows first, and then columns, and then handle every single 16 by 16 cell to decide what to plot, and then it creates an SVG string, which gets nested inside one big outer SVG string, and that's what gets sent to the control on the board and displayed. So the main map calculated measure is probably the most interesting calculation in here to work with. And if we see the data for this, show data, what this is going to do is possibly, sometimes you see the actual SVG. If I hover, maybe I think I would need to put the main map into something that's going to display the text. But it's a very large amount of text, which is a whole bunch of SVG statements to say, hey, draw a little square here or a line here and use this color. You can style sheet it up so that it's very easy to just change one or two properties, and it'll change the color or effect like that. So that's kind of cool. So then when I built that, I thought, I wonder what would be involved to take this maze and create a 3D version. Think a la early Castle Wolfenstein Doom. And I was actually quite surprised how easy that was. I used exactly the same mapping engine, so I could import the same CSV file, and based on the CSV file, that would decide where walls should be and where floors should be. And what I needed to do was handle how to convert these XY values of where walls should be into XYZ values, so that I could add height and I could add wall panels. And let's have a look to see what that looks like. So we've got Temple of DAX 3D. If we hit the play live button, this will take us to the version the published version online. And actually, while I'm doing that, I'll load up the PBIX file. Cool. So this is the published version, play live. And if we click to start, same concept. We have an area for SVG. And what we can do is, using the custom control here, up and down move you forward and back, and side to side spin you 45 degrees. Now we are this red dot here, so we're looking down the top, so we can see the left hand wall there is the wall here. Let's just move forward to get outside, or just past this, the letter M. We're going to turn, move down through here into the open. And spin around a bit, you get the idea. We'll need to probably go a bit further. Okay, so this is exactly the same as the 2D version. I'm using SVG to create a bunch of polygons and objects to plot on the wall. The tricky part I had to do was just figure out some maths to do 3D projection onto a 2D plane. So how do I take coordinates that are X, Y, Z in a 3D world and create a view that plot onto a screen? And then based on that, knowing the position of where you are and where you're looking, what effect do I need to do there? Now, I just used an internet search and I Googled 3D to 2D projection. And that took me to this Wikipedia page. This is in my blog. I'm doing the very short version of this. I scrolled down to the section on perspective projection. This is this whole concept of disappearing points and angle. And I found this wonderful calculation that went right over my head. Fortunately, I found this calculation, which is the non-matrix implementation, where you see a C, that's cosine, where you see an S, that's sine. And I just ported that to DAX. Now let's have a look to see what that looks like inside DAX. Because in my map, there's not a lot to it. My main map, I'm conscious of time here. When we scroll down into it, all the 3D logic is being handled just by this block of text here, which is spaced out. There's not a huge amount to it, but this directly maps the code that I grabbed from here. So if you were to study this side by side, you would see that these brackets and these signs and these operators actually just match this nicely. Now, I'm not going to pretend to understand it. I remember when I was 15 doing this kind of work with geometry at high school, and I swore I'd never ever use it for real. I have done. I was lucky that once I wrote this into the DAX and then plotted it, it worked. So I didn't have to worry about understanding it fully. So please don't email me and ask me too much about cosine and sine and cos, because I won't be able to answer you. But once you port that into DAX and then wrap that into some concatenate EX to generate some SVG objects, then you can paint a picture that effectively converts your 3D set of coordinates to 2D sets. Now what I'm going to do is to show you the DAX working using the map is hit my refresh button. That's going to read in that same data file that we modified in Excel about 5 or 6 minutes ago. And what we should hopefully see is some objects appearing and disappearing here. And if I was to go and explore those, there we go. Let's make sure that that has worked properly. So we're going to turn to the right, shoot down here, go button. There we go, there's that wall I built. So you don't have to now. This is fully 3D, so I could put a slicer on here that controls height and cheat and rise myself up, and the game perspective matches that. So have a play, download the PBIX file, have a look at my blog site. If you're interested in this in more detail, please reach out to me on Twitter or LinkedIn. If you do have any questions, I'm always keen to help people out. I'm probably going to continue this by building some additional games. So I'm wondering if there are any questions. We've got 5 minutes to go, assuming I haven't been cut off.
Hey, Phil. Yeah, I guess the one question we have, they were asking what version of Power BI you're running.
I just run the latest version, although most of the things, everything I've shown you today would work in a version probably October or November. I think the SVG stuff came online around June or July. So I'm not using any cutting edge features or functions that have been added just in the last few months. In a couple of the games, I have taken advantage of the folders in the field view, but that's not essential to get the game. So yeah, I would recommend something that's at least 6 months old, but it's not essential.
All right. Can you also go back to your first slide with your contact? I think a couple people are asking for your email and Twitter handle.
Cool. So my Twitter handle is @PhilCmark. That's probably the best way to contact me. Please feel free to DM me or tweet me. I have written a book on Power BI, beginning DAX with Power BI. This is a pretty good place to start. There's a lot of beginner content. There's some intermediate content and a little bit of advanced content. I've just finished off the follow-up book to this, which is the pro version of DAX, which is a lot more advanced content. Between them, you should get an awful lot of value. In fact, what I'm going to do is type in here how to find the book. But while I'm doing that, do you have any more questions? It's quite a lot.
I think someone asked, you found that updates break complex DAX code after an update, or are updates stable?
For me, I've pretty much built all of these games in just DAX, and DAX is quite stable. What they tend to do is maybe add a function very occasionally, and they're very good at making sure that existing functions always behave as expected, despite Power BI being updated. The layers that I put on top of that are bookmarks and buttons, and again, I found them to be quite stable. Like the biggest problem I had was probably in that Sudoku game, where I used a large number of objects on a reporting canvas, and it started to slow down quite heavily, just because of the nature that each object is an iframe on its own right, and it has its own block of JavaScript that's chatting away to all the other objects. So it's unlikely in a genuine business scenario you're going to need so many objects, but hey, it's something like this, playing with games where you explore and find where those limitations are. So I think I found the limitation on objects on a page, but I haven't yet found limitations on, say, the length of the string that you can use to generate a dynamic piece of SVG to display a 3D map that you can control walking through. If you can do that, then you can, there's probably quite a lot that you can do. It's certainly, if you're sitting trying to figure out how to get a number in a cell and you're scratching your head wondering if DAX is the reason why you can't do it, if we can do these wonderful things in DAX that I've shown you hopefully here today, then hopefully it gives you a bit more confidence and has reset your boundary about what is capable in DAX. And I'll just put my book, aka.ms/practical DAX. This is a pretty good place to go if you want to start learning more complex stuff about DAX. So I'll jump back to that slide.
All right. Several people just wanted to say thank you for the presentation. They said it was a very fun and interactive webinar.
Oh no, thank you. Oh, that's cool. Well, yeah, thanks everyone for dialing in. And yeah, please keep in touch.
Yep. Everyone that joined the webinar or that missed it, the session is being recorded, so I'll upload it to our YouTube channel, and I'll send an email to the whole group probably around Thursday or Friday when it's uploaded. Philip, thank you for presenting, and best of luck at Microsoft.
No worries. You'll be hearing from me, hopefully.
Yep. Sure, we'll be hearing you speak again.
Cool. Thank you. All right. See you later.
Alrighty, everyone. Bye.